P, Q and R are 3 points on a circle with a centre O and a radius length 3 centimetres. So here's our circle, here's our centre O, and here's our points P, Q and R. So the radius is 3 centimetres. So from O to Q is 3 centimetres, from O to P is 3 centimetres, and from O to R is 3 centimetres. PQ is 4 centimetres, and the angle POR is 120 degrees. So POR, this is 120 degrees. Part 1, calculate the angle POQ. So POQ, so this angle in here, to 2 decimal places. Part 2, express the angle QOR in radians, correct to 3 decimal places. So QOR, so this angle in here. Part 3, calculate the area of the shaded region to 2 decimal places. So part 1, calculate the angle POQ to 2 decimal places. So POQ is this angle here. So we actually have a non-right angle triangle. So we're either going to use the cosine rule or the sine rule. So since we know that the radius is 3 centimetres, then this radius must also be 3 centimetres. And we obviously have this side here 4 centimetres. So we have 3 sides and we're looking for an angle, so we're going to use the cosine rule. So I've drawn the triangle out here separately. So we have QPO. So this is 4, this is 3, and this is 3. And we're looking for this angle. So since there's a capital A in the formula for the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos of a, then the angle that we're using has to be labelled as a. So the side opposite that is lowercase a, and then the other 2 sides are b and c. It doesn't matter which way we label them. So using the cosine rule, a squared becomes 4 squared, b squared is 3 squared, c squared is 3 squared, minus 2bc is minus 2 by 3 by 3, and cos of angle A becomes cos of angle POQ, or you could just call it cos of angle X. 4 squared is 16, 3 squared is 9, and 3 squared is 9, 9 and 9 make 18, minus 2 by 3 by 3, well minus 2 by 3 is minus 6, by 3 is minus 18, so we've got minus 18 cos of angle POQ, or cos of angle X. So we're going to bring the 16 over the other side, it becomes minus 16, and 18 minus 16 is 2. We're going to bring the minus 18 cos of angle POQ. So we have 18 cos of angle POQ is equal to 2. So dividing across by 18, 2 divided by 18 is 0.1111. And the inverse of this, so cos to the power of minus 1, by pressing the shift button gives us 83.62 degrees. So this angle here is 83.62 degrees. Part 2, express the angle QOR in radians, correct to 3 decimal places. So the angle QOR, so this angle here coloured in green. So the angle QOR is going to be 360, take away the angle POR in red, plus the angle POQ in blue. And the reason for that is angles around a point add up to 360 degrees. So if we have this angle, and we take it away from 360 degrees, we're left with the angle we're looking for. So we're told in the question that the angle POR is 120 degrees, so I've drawn that in there, 120 degrees in red. We worked out in part 1 that the angle QOP is 83.62 degrees, so I've drawn that in blue. So taking them away from 360 degrees leaves us with 156.38 degrees. So the angle in green is 156.38 degrees. So to change degrees to radians, we multiply by pi over 180 degrees, because pi is equal to 180 degrees. So we have 156.38 multiplied by pi divided by 180 degrees. So into the calculator, we have 156.38. We stick on a pi by pressing the shift button on the pi function. And then we divide by 180 degrees and we're left with 2.729345884, and rounding to 3 decimal places we get 2.729 radians. Part 3. Calculate the area of the shaded region correct to 2 decimal places. So the shaded region is a segment of a circle. So a sector is a piece of the circle that goes into the very centre. It's like a pizza slice. A segment is a piece of the circle that has a chord cutting through it. So this is the chord. That's a line that cuts through a circle that does not go through the centre, because that would be a diameter. And then this is the arc that's connected to it, and the inside area of that makes a segment. So the shaded area is going to be the area of the sector OQR. So OQR, so this sector, minus the area of the triangle OQR. So OQR. So if we get the area of this sector, and then we get the area of the triangle, and we take the area of the triangle away from the area of the sector, we'll be left with the area of the segment, which is the grey part, the shaded part. So the formula for the area of a sector is going to be 1/2 times r squared times theta, which is the angle. This formula is given to us in the formula book, and this is the formula we use if we are working in radians. Otherwise, this is the formula that we use if we're working in degrees. Both of these formulas are given to you in the formula book. The area of a triangle formula for a non-right angle triangle, which this is 1/2 AB sine C. So what we're going to do is label our different bits and sub it into our formula. So the r is the radius, and we know that that's 3. So we sub the r for 3. The angle, theta, is 2.729 radians. We worked that out in the last question. So it's going to be 1/2 times r squared times theta. It's going to be 1/2 times 3 squared times 2.729. And that's going to be minus AB sine C. So the A is the radius 3. The B is the other radius 3. And then we have sine of C, so sine of the angle. So this time we're going to use the degrees, which is 156.38. So it's going to be 1/2 times 3 times 3 times sine of 156.38 degrees. We have to use degrees for the area of a triangle formula, whereas we can use radians for the area of the sector. So putting this into the calculator, we get 12.2805. Putting this into the calculator, we get 1.803. And subtracting leaves us with 10.48 centimeters squared. So the area of the grey part, the shaded part, the segment, is 10.48 centimeters squared. Make sure that you're in rad mode, radian mode for this. Or we could have used the other formula and used just the degrees. So the other formula is pi r squared times theta divided by 360 degrees. So the theta is 156.38 over 360, and then the area of the triangle part stays the same, and it will still give you 10.48 centimeters squared. This way is probably a little bit more straightforward. It doesn't matter which way you use though. So the area of the segment that's shaded is 10.48 centimeters squared.